Welcome to Saxon Math Course 3, Lesson 108, Similar Solids. Now, we've talked about similarity in two-dimensional figures. Remember that similar figures are the same shape in either the same or a different size. That means that if you take any specific side, length, or dimension from one figure and then create a fraction with the same corresponding side in the other shape, it will create a fraction which is the same for every set of corresponding sides or dimensions in those two shapes. So, they have the same shape and all corresponding sides are proportional. When we find that fraction, we call that fraction, that relationship, the proportion between the two corresponding sides, the scale factor. Now, we've gone over a lot of things about scale factor. Remember, the ratio of the dimensions, one side over the other, is the scale factor. The ratio of the surface areas is equal to the scale factor squared, and the ratio of the volumes will be equal to the scale factor cubed, or to the power of 3. So, example 1 says an architect builds a scale model of a building with the scale of the model is 1 inch equals 5 feet. Part A says, what is the scale factor from the model to the building? Now, looking at this, you might think it'd be 1 to 5, but it's not 1 inch to 5 inches, it's 1 inch to 5 feet. So we need to know how many 1 inches are in 5 feet. Well, to do that, we would have to multiply 5, the number of feet, by 12, the number of inches in 1 foot. 5 times 12 is 60, so it's 1 to 60. The scale factor here being 60. Now, the surface area of the building is how many times the surface area of the model. That's a question asking about the ratio of the surface areas. The ratio of surface areas will be the scale factor squared. So we'll take 60 and we'll square it. 60 times 60 is 3,600 because 6 times 6 is 36 and 10 times 10 is 100. Part C of this same example says the volume of the building is how many times the volume of the model. Well, we're going to take our scale factor and cube it. So we're going to do 60 cubed. Now 60 cubed is 60 squared times 60 again. Now we're going to drop a 0. 6 times 0 is 0. 6 times 0 is 0. 6 times 6 is 36. 6 times 3 is 18 plus 3 is 21, which means we get 216,000 times as big. Now, example 2 talks about an ancient sculpture. It says that to cast a bronze sculpture, an artist carved the sculpture in beeswax first. Then the wax was covered in liquid clay and heated. As the cast was heated and the clay hardened, the wax melted away. Melted bronze was then poured into the hardened clay mold. When the metal cooled, the clay was removed. If the artist was commissioned to create a similar bronze figure 10 times larger, how much bronze would he use? Now, the majority of this question is just background information about how they make bronze statues. The important thing here is we're talking about how much of material will be used to create a three-dimensional object. The amount of material in a three-dimensional object is its volume. So we use the amount that is being increased by 10 times larger. That's our scale factor. Our scale factor is times 10. The ratio of the volumes is the scale factor cubed, so we'll do 10 to the power of 3. Which is 10 times 10 times 10, or 1,000. As you can see, the important part of this lesson is remembering these relationships here. The ratio of the dimensions, which can be found by putting the dimensions of one shape over the dimensions of the other, is your scale factor. Once you know the scale factor, you can find the ratio of the areas and the ratio of the volume by doing scale factor squared for area and scale factor cubed for volume. And that's lesson 108. Make sure that you take good notes. Make sure you study the things inside this box especially. and get the rest of your homework done. Stay safe, stay inside, and wash your hands.